I'm Dale Hamilton, Assistant Professor of Computer Science at Northwest Nazarene University. Also just recently finished a PhD in Computer Science at the University of Idaho. My doctoral research was using drone imagery and developing artificial intelligence analytics to map post-fire effects. Where did the fire burn and how severely it burned? I have on my left three of my computer science majors, Nick Hamilton, who is a senior at Northwest Nazarene University, Casey Lewis, who's also a senior, and Alicia Chavez, who is a sophomore studying computer science at NNU. So essentially what we're doing is using developing artificial intelligence analytics that allow us to bring a drone in, and after the fire's out, we're flying the burn area, looking for where did the fire burn, looking at black ash versus burned vegetation, and then within the area that's burned, looking for white ash, which gives us an indicator of biomass consumption. So in explaining a little bit more of how the artificial intelligence works, I'll let you guys go ahead and talk a little bit more about how we're doing that.
This port vector machine basically will plot your values, so your red, green, blue values, and then it tries to create what we call hyperplane. Just think about it, if you have 3D space with red, green, and blue, the hyperplane is a 2D plane that separates, like let's say, burned values and unburned values, and it creates an optimal margin, a lot of linear algebra magic to help decide when you have a new pixel, is it burned or unburned. And also we can do this for how badly it was burned. And
looking for white ash versus black ash. So Alicia, if you wouldn't mind talking a little bit about what the studies found as far as the accuracy of the two algorithms.
So after testing both algorithms, the KNN and the SVM, we saw that the SVM was a lot more accurate than the KNN was.
It was in the 90%
in the 90s, while the KNN was in the 80s.
So, both of them, and actually, why don't you talk a little bit about the spatial resolution of the imagery, how big the pixels are in using drone imagery.
So, especially compared to like Landsat, a satellite, our pixel resolution is so much better, so it's a lot easier for, at least for these algorithms, to pick up what is in these, because it's we can see what's burned and unburned better than we could using satellite imagery, which is just usually big blocks of color pixels. What are the...
Yeah, so the spatial resolution on Landsat is 30 meter. What's the spatial resolution that we're getting with the drones?
Well, flying it at 400 feet, which is as high as we can legally fly it.
With the FAA?
That's about 5 centimeter resolution.
So the big thing here with hyperspatial resolution is instead of having the problem you have with Landsat 30 meter pixels, a lot happens in 30 meters. We have mixed pixels. Drone imagery, 5 centimeter, it's the other way around. The things we're looking at are comprised in the image of multiple pixels. So for example, with drone imagery, we can actually look at a tree and go, well, that's a ponderosa pine, that's a Doug fir. Or as we're looking in the burn area and go, well, this is just black, partially charred vegetation, versus we can actually see tendrils of white ash from what before the fire was a sagebrush.
So you're collecting data after the fire burned. You're looking at fire effects, right?
Yes, we are looking at fire effects. We are not dealing with active fire. We've got the whole if you fly, we can't sort of thing. I don't want to have my drones anywhere close to any remote possibility of being, conflicting with air resources over a fire.
How long have you been working with drones?
We started my doctoral research 4 years ago. Nick's been with me just about that long. Up until this point, we've been funded by Idaho Space Grant Consortium, which is NASA funding, came through there. This year, we're changing our funders. We're actually working in collaboration with the Boise National Forest.
And what kinds of drones are you using?
Currently, the ones that we're using are, we have DJI, we have one Inspire, and 2 Phantom 4s.
How long can these drones stay in the air?
20 minutes.
It's operational flight time. They say 30 minutes, but last thing you want to do is have the thing run out of battery on the way back. So the Inspire actually has slightly less flight time, but because it flies at 18 meters a second versus 10 meters a second for the Phantoms, we actually get more area covered with the Inspire. It also has the advantage of being larger. It's easier to see from a distance.
So what do you hope to do in the future with drones?
Well, I think your senior project you're working at is very exciting. Why don't you go ahead and talk about that?
So currently, when we have post-fire area, we will go out there with our drones and we'll take it up, we'll fly that fire line, and then also map the area. So what my senior project is I'm creating the drone to do the software for the drone to do it itself. So basically, we want to be able to say go, drone will fly up, find the fire or the post-fire area, fly the outline, the perimeter of that fire, and then also map the inside of that, so that we don't have to. It should make it more efficient and easier for our like the Boise National Forest, people like that. They can have these drones with them. They don't have to worry about flying this themselves, and it'll do that for them.
And so when we talked about the support vector machine versus KNN algorithm, that was just one of the three dissertation hypotheses we worked with. Another one was kind of what we refer to as the well duh question, which was, can we map fire effects more effectively with 30-meter imagery from Landsat or 5 centimeter? Well, we know what the answer is, but no one had published it, so we went ahead and did that. And there's Nick, why don't you describe that process and where we see going forward with that research?
So yeah, basically, we compared the accuracy of mapping like 5 centimeter drone imagery versus like 30 centimeter.
30 meter.
Yeah, 30 meter resampled drone imagery. And we just found that the 5 centimeters way better. But the problem with the 5 centimeter is there's just tons of data in that. We talked to the Boise National Forest and they said don't send us the 5 centimeter because their servers can't handle it. So
Huge amounts of data.
yeah. So what I'm going to be working on is figuring out that happy medium of accuracy and not too much data.
Looking for the optimal spatial resolution.
Okay, thank you very much. I appreciate it.
Thank you.
Sweet.
Thank you, Bill.
Thanks.